Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
We ended our previous video tutorial 119 on comparing the results, the predicted results from our spatial regression models, or some of them, to our previous models being the multiple regression time series and the random forest time series models. And we generated those predictions within RStudio, and then we exported them or convert them into a raster, and we exported it into QGIS, and then we did the comparison. So I received a couple of comments and questions regarding spatial regression. So so this video will then specifically focus on spatial regression. I'm not aware of, I may be wrong, where the spatial regression models were actually converted into prediction raster images and then compared in QGIS. I may be wrong, but I'm not aware of that. Anyway, that doesn't matter. Let's quickly have a look. So let's go back to our R. Okay, so where we all started. Okay, so we start with the models from Berkeley Academy. If you want to see the models, he has produced a sheet with all the models in there. They all are. Okay, and they are available on his website. Okay, so there's the OLS model, there's the spatial lagged X model, the spatial Y model, the spatial error model, the spatial Durbin error model, the spatial Durbin error add lag, etc., etc. And there's another site there as well where he's got all of the models nicely in one specific page where you can work with. Okay, so here's all, I think there's 8 of them, if I'm correct. We'll have a look at it now. There's 8 spatial regression models, and they all are variations of the spatial X, or independent, or the spatial dependent, or the spatial error. They're all combinations of those 3. So you play around with those 3. Remember from time series, we just add the neighboring spatial weight matrix, and when we generate the models thereof. Okay, so there they are all very nicely presented, etc., with the codes in R and all of these things. So what we're doing now is we're just taking all his models or regression functions, and we're just generating predicting images of that. We're generating the predicted values or the fitted values. We converted that into a raster image. We export it into QGIS, and voila. Okay, so to do that, we need to create, as I said in the previous video, an empty raster file that has the same extent, parameters, width, height of the original NDVI dataset. So basically we create a blank NDVI raster, which we are going to populate with the predicted values for each pixel or each cell. So what we first have to do is create that empty raster file. Okay, we have to create that, and we call it a raster template. Okay, so that's the empty raster file, and it's based on the NDVI, which is our shapefile, our raster shapefile. The original one with which we've loaded NDVI. Okay, NDVI 2. Let's go and have a look and see. This is how it looks with all our X and Y's, etc., etc. So NDVI 2, we created a shapefile of that. I just want to find out where exactly we've done it. There's so much of these codes now. Let's have a look quickly. We see. I think I should be, there we go, the NDVI. NDVI is the CSV file, and that we've created the X and Y coordinates, and we plot that. So if we plot it again, you'll see there's the file with all its, if I zoom it, okay, so there's the file with all its cells, its pixels. So that's essentially what we're creating, a blank one. So what we're now going to do is when we rasterize it, we're going to add the predicted values for each of these cells. So that's essentially what we're doing. Okay, we're taking that shell or that template, as we call it here. There we go. We're creating that template from that raster file. Okay, resolution you can play around with. This is just the size of the pixels itself. And we're going to add the coordinates to it. We're going to give it a coordinate referencing system, and we're going to save it as a raster template. Okay, so that's what we have to do, standard practice. Okay, so all you need to do is add your file there, your NDVI file or your temperature, whatever file you just want to create it, you're empty on, and we're going to just create then that blank raster file. So that's step number one. Okay, so now, and that's got nothing to do with the spatial regression models per se, but it all has to do when we want to rasterize our predicted values. Okay, so we have to do that. Okay, so that would be my step one. My step one is to generate my neighbors, my spatial matrix. Okay, my spatial matrix. And that's how we do it there. I'll do a separate video for how we do it in Geoda. We can do this in RStudio. And Berkeley, within his videos, has a tutorial on how to create these spatial weights matrices within R. But it's easy to do it in Geoda. Couple of buttons and voila. It's okay. So we'll do a separate video on how to create these spatial weights matrices within Geoda. It will be coming soon, within the next 2 or 3 videos. Something to look forward to. Okay. Anyway. So all we do is we create that spatial weights matrix within Geoda, and I use a queen rank 1. As I said, don't worry about it. I import that, and I link it to my NDVI file. You see, there's my NDVI file, and to these index values. Okay, and I give it a name, NDVI queen neighbors. There's my summary of it. We can do a summary of it. It will just tell you how many, the first line here is number of neighbors, and these are the number of points. Remember, these are points or cells. Number of points, and the number of neighbors for points. So the largest number of points, 4,000, has 8 neighbors. Some has 11 neighbors, some have 7. Okay, but there it is. Okay, so that's it, and then we just create a list with it, and we can then generate the summary of that list, and that will just give you, give you the same numbers plus minus, and we can plot that. See if we can plot it. It should give you. Let's see if we can plot this. It should give you the spatial weights matrix. No, we can't do that. Okay, so don't worry. In Geoda, we can go and plot it. Anyway, so point 1, step 1 is the empty raster file, and 2 is the spatial weights matrix. Okay, so now we're all set to go. Now I'm not going to run the OLS one. Yeah, there's no need to run the OLS. So we'll start, as I said, with there's 1, 2, 3, 4, 5, 6, 7. There's 7 of them. Okay, so the first one which we do is the SLX. If we go to his cheat sheet, there's the SLX. There's one. It's called the spatial lag. You'll see there is the term, okay, which is the spatial matrix, which is this sign here, times the weights for all the x's. So my neighbor's temperature influences my NDVI, my neighbor's elevation influences, and that relationship is the weight matrix. So we've done that in the previous video tutorial. Okay, so we've done that. Then we just press the summary button, I'm not going to run it because this takes very, very long to run. So I've ran it last night through the night, all of these models. So I'm just going to press the summaries. Okay, just going to press the summaries. There it is. And as I said, we can't use this within our calculator within QGIS, our raster calculator, because the spatial weights matrix, this one here, we cannot upload that. So these lag intercept, lag elevation, lag rain temperature must be multiplied by the spatial weights matrix of each of our neighbors to see how much of that values influence my NDVI. Okay, so that's why we're going to generate the image, the raster image within QGIS, within RStudio. Okay, so once I've done that, now I'm going to create my predicted values. Okay, so I'm going to create my predictions. What I can do is I can also say fitted, and that also generates, come on, that also generates my predicted values. So let's say fitted. We can do that, and I'm just going to put reds in there. And there it goes. If I press fitted for my regression, you'll see it creates this data points here. So that's all the fitted. So for location 1, it's 0.36, the fitted NDVI, not the actual, the modeled or the predicted NDVI value. And for point 2, now point 1, if we go to our NDVI file, would be that one there. So coordinate. So the actual value of the NDVI is 0.45. The fitted value is 0.36. For port 2, the fitted value is 0.44. The actual value, the fitted value is 0.35. So what we're displaying on this list is the fitted values for each of these ones, for each of the actual values for those locations. So this is basically another point layer. Okay, but I'm not interested in the point layer. I want to generate a raster image of my model. I'll come back to the points one, but later. Okay, so once I've calculated, then now, so I need to calculate predicted, which is, this is the fitted values, which is that, and the data points, if I want to, I can add this as well now. Let's see if I can, if I add this, if it makes any difference. I run it without adding. With adding that, it shouldn't be too much of an issue. Nope. Let's leave it. Well, let's quickly go there. I can include it like that as well. See if we can do it. Works perfectly without it. I'm just quickly testing whether if we add it, if it will make any. Yeah. So it just the format. Then, so I'm taking my model. There you go, the model, and I'm applying and I'm using the data, but exactly the same as in the model itself. I'm applying the list, exactly the same, and I'm just predicting it from that. And I'm giving it a name, which is predict NDVI SLX, which is SLX there. Then I'm just adding. Now I'm going to add the coordinates, which is the coordinates in here, those coordinates. I'm just going to add it to the table, to my table that I generated here. There's the coordinates of NDVI. I'm using this coordinates. Okay, and I'm just going to run it. So it will add the coordinates now to my predicted values. Okay, it's going to, and now I take my predicted values and with the coordinates, and I am now importing it into my raster template. You'll see there's the raster template. So I'm taking the coordinates, I'm taking the values, and I'm populating my blank raster template by using that script. And then I can then plot it. And there it is. And I'm going to write it to as a geotiff file. And I'm writing it as a geotiff file. I have already, it's loaded, so I'm not going to overwrite it now. So there it is, easy peasy. So I generate my model, I generate the predicted values of my model. I link the predicted values with the coordinates. Then I take the predicted values and the coordinates and I uploaded it into my blank raster file. And then I plot it and I export it. So that's in a nutshell the steps that we now do. So as I said, now it's exported to my, if you go to files here, it will be NDVI prediction, NDVI prediction, which is SLX. There we go, prediction SLX. There it's there's the file. Okay. In fact, there's two of them. Oh, there's just one. It's just there's the SLX one. Okay. Yeah. So from here, obviously, we can now, and there's how it looks. Obviously, we can display the actual and the predicted one next to one another in RStudio using the. Let's quickly have a look where. Okay, so we're going to display them. We're using this function. Let's have a look quickly. I don't actually want to do this, but let's quickly just do this for the sake. And it's going to be two images in rows and one two images in one row. And the two images would be the actual. Okay, so let's quickly. So it will be the predicted one, and we're going to also do the actual one. Let's do NDVI. Let's see if that works. See if this now works. Let's quickly just delete these ones, and we're gonna run it. Let's see. It should display the two images now next to one another. At some point, I don't know why it's taking so long. That's not predicted, it's actual NDVI. Actual NDVI. Let's just quickly take that away again. Write it. I'm not sure if this is the right. Just want to quickly go up. Yeah, no, it's going to present now all the values. It's not what I want. It's this one here, raster value. That's the original raster value. Let's make sure it is uploaded. Okay. Now there's another issue here. But anyway, we first see where is it now? This one here. Sorry. There we go. Sorry, it should be one row and two images. Okay, so let's run it. Shouldn't be next to one another. There we go. We can export it. We can zoom it. There we go. It's just the color schemes, which is obviously quite different, and that's why. And it's also different coordinating system, so it's actually a little bit pointless. Anyway, you could do that. There is, and we do that for the same for our spatial lag one, exactly the same. We do it for our spatial error one, exactly the same. Then we do it for our Durban error. Now let's have a look and see what our Durban error looks like, which is 5. Let's have a look and see. Spatial Durban error. Here it's add a lag x to the spatial error model. So that's why I say we combine now the spatial lag x and the spatial error model. So that's what we do here. We combine the two. You'll see that there's a wxy, that's the spatial lag term, which is included there, and then the spatial error term, which is included there. So this is just those two models combined. And we run it. Then we do a Durban error model, which is my 5 Durban error model. Then the Durban model itself, which is that one. Let's have a look and see what that looks like. This is a lag X to the spatial lag Y model. So these two are just, the one is the X's and the errors, and the other one is the X and the Y's together. And we run it. So all of these ones we can rasterize the predicted value. So all of these up to there we can predict it. Now we're generating the Mansky one and the Sarah one. Now the Mansky one and the Sarah one, sorry, is not on this one. Let's see, nope, it's not on this one, it's on this one. So come on. Why? Okay, so there's the Mansky one. So this now includes the spatial Y's, the spatial X's, and the spatial errors. Okay, so that's what that one is. And then where's the Saru model? I don't see it now here somewhere. Spatial error, there we go. Saru model is where that is 0, so that is just the, yeah, so that doesn't include that part there. Anyway. Okay, so there's two additional ones. You'll see there's the Mansky one, which is all of them included, and there's just the Saru one. Okay, now with these ones we cannot generate a predict image. We cannot do a predict image, this thing here. It doesn't work with it. So let's just see how the summary looks like. I'm not going to run the models, it takes forever. Okay, so it now has intercept, elevation, rain temperature, etc., etc. There's the numbers. Let's see what it looks like. You see, it only focuses on itself. Doesn't have the spatial X's. But for these two models, sadly, we cannot rasterize them. Well, I'm not aware of. I don't know how to, because it doesn't allow the predict function. So it doesn't allow this predict function. If you try to do the predict function, it throws you out. So for example, let's go there. So I'm going to copy that now. So let's go there. We paste it in. Predict. Let's call it. I don't want to spend too much time on just the M. Predict rec 7. Points, all the 7. So we're just going to create it. Okay, so you'll see we run, it says no such predict method exists. So it's not possible, according to my mind, therefore, to generate a prediction from this model to predicted values for whatever reason. However, I can generate the fitted values. Here I can generate the fitted values. And its value 1 is 0.41. If I go to my NDVI, the actual is 0.45. This gives me a value of 0.41. So you can see it's much closer or much more accurate than the previous ones. If you can remember, this one was 0.36 and things like that. Anyway, so let's not deter from that. So what I'm going to do now is I'm going to export the fitted values. Okay, so I'm going to export the fitted values. Don't worry about this. It's not an error. It just gives you a warning, but it's not an error itself. So it's not an issue. So I'm generating the fitted values. I'm storing the fitted values from my model. And then I basically add those fitted models to my original, this one here, data set, because I want to now, because you see these ones don't have X and Y coordinates, it's only the values. Okay, but we know if you go into you'll see there's 0.5, it has its data point. So what I want to do is want to add those values to this file. Okay, so that I now match the value with its geometry. Because as it stands here, this table here, this list here, doesn't have geometry. It's only got the fitted values. Only has the fitted values. So I want to take that fitted values and I want to add it to my original NDVI file, this one here, because it within this file it has the X and Y coordinates. So that's what I'm doing there. Okay, and then I'm exporting that file. Then I'm writing it as a CSV to my folder. And I'm doing exactly the same with this SARAR model, which is lag Y and lag E. Remember this one, lag 7, that actually should be before that. Lag 7 has lag Y, lag X, and lag Y. This one here. It's got all three terms. This one only has lag Y and lag E, which is similar to, I think, 6. Is 6 not also not, yeah, I think 6 is also just that. Anyway, and I do the same. Also, 8, you cannot generate the predicted values. Also doesn't allow you to do that. Okay, so both of these ones, 7 and 8, doesn't allow you to do predicted. It doesn't have the function. So, as I said, what we do is we generate the fitted values. We generate the fitted values and then save those fitted values for each of those point locations, i.e. for each of those centroids. And we've got the coordinates for those centroids. So I saved it. What I then do, okay, and this is where it becomes a little bit fuzzy, or a little bit more, not tricky, but let's see. Okay, let me not jump the gun. So now I basically, couple of things. Now I've already done this. I go to my layer and I add the CSV files for both of them. You'll see there it is, both the CSV files. Okay, I add those two CSV files. Remember, those are the ones that I've just created here. There we go, Mansky and Sarah. Okay, Mansky and Sarah. And I open them. I'm not going to do that. I've already done it. Okay, and then once I opened, okay, by the way, this is how it looks. That's the Mansky one, etc. Once I've added them, okay, I don't want to work with CSV files. I simply just go to I right click on it, right click, and I export them, save features as shape files. So I save it as CSV files through RStudio, and I bring that CSV files into my QGIS, and within QGIS, and I save them as shape files. Save them as then for point layer shape files. Point layer shape files, and there they are. Okay, so, but I don't want to compare a point layer with a raster image. Now, so I want to convert these two point layers into raster images. As I said, we can't do that in RStudio. RStudio doesn't allow that. RStudio doesn't allow it for these two models. Okay, it doesn't allow it for these two models. So I'm going to manipulate it in QGIS. Now we can't rasterize it because it's points, it's not polygons. So we can't use the standard rasterize, like conversion from vector to raster. We cannot use that function because it's not polygons, it is points. And therefore we have to find another way. And remember, within one of our previous video tutorials, let's go to my QGIS, smart map. I'm going to use interpolation. Okay. Which may or may not be the best option, but that's what I got so far. That's what I have so far. I'm going to use smart map to interpolate, because remember, what I'm doing in interpolation, remember I've got these known NDVI values. I want to estimate, you see if I unselect this, Okay, so let's just keep one of them. You see, I have a NDVI value, a known value. And what I want to do is I want to estimate the rest of this cell based on the value of this. So I want to assign the cell value equal to this raster value. So that's in essence what I want to do. I want to say, okay, that's now the center point for that cell. Give that whole cell the same value as my known point value. You see, most cells should have only one value. Most of them should only have one value. And therefore we can try to, and that's what we do with interpolation. We're assigning values to the cells based on the known value. Because remember, what I have now is this. I've got unknown NDVI. So all this NDVI is unknown. I've got a known NDVI value that is there. So I want to assign that. I want to generate the NDVI values for all these unknown locations based on these known NDVI values. So that's in essence what I want to do. Okay, and that's what we use the interpolation. So I'm not going to go through the whole thing now, but basically I'm using my smart map. You can go through that video. It explains the ins and outs of smart map brilliantly. And I then generate interpolation images for those two models. Okay, so for these two models, in a nutshell, I generated the fitted values. I converted that fitted values into a point layer shapefile in QGIS, and within Smart Map I converted that point layer shapefile to a raster image. And that's what I then sit with. There it is. And there it is. There's the Manskin one, and there's the Sarah one. And you'll see they're almost identical. In fact, you'll see there's almost no change because the two models are very, very similar. If I go to the spreadsheet, NDVI, you'll see there, if I go to the actual spreadsheet, you'll see the values are very, very similar. So they're not identical, but they are very similar, and that's why within my raster images there's very little. So now I've got, so let's go back again. So there, remember, there is 6 of them. There's 6 of them, excluding the OLS. So there's my spatial X, my spatial Y, my spatial error. So that's a building block, that's the 3. And now that's just deviations of that 3. My Durban error, my Durban one, and my Manskin one, and the Sarah one. So that's 7. So there's the 7. So have a look. I go into QGIS. So have a look at them. There's my spatial X, spatial Y, spatial error, Durban one, SDM one, Mansky one, and Sarah one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. They are all 7. So now as well, I have the LQS time series model. I've got the robust linear model. I've got my normal multiple regression model, and I've got my random forest model. So now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, I've got 11 models. 11 models. 7 spatial and 4 and 3 time series and 1 random forest. Okay, so let's go to my selection tool. Let's go select any location, and let's go and have a look and see what the numbers look like. So let's start with the actual value, NDVI value, 0.35. That's the actual NDVI value there. Okay, so let's go and have a look. Random forest, let's start with the bottom one. Random forest, 0.30. That's my random forest. multiple regression. Let's have a look and see what that value is. 0.302. So that's much closer than some of the previous examples. Let's go and have a look at my robust linear regression. 0.37. So in this case, it's actually better than the random forest one. QGIS, LQS. Look here, 0.31. So that's actually quite good. So that's the actual value, the random forest, and my 3 time series models. By the way, there's a number of time series models that we still have to include here. We've only done those 2. If you can remember, in RStudio there's also about 7 of them, so we're going to do them as well. So let's start with the SLX, the first spatial one. That's bad. That's spatial X. Let's have a look at spatial Y. There's spatial Y. There's spatial Y, much better than the spatial X. There's a spatial X, there's a spatial Y. We can do, then it's spatial error. Let's have a look and see what that one looks like. 0.3, nope. Then we go into the combinations, which is the SDM. Let's have a look there. That's that combination, 0.29, so that's bad. SDM, let's have a look at that combination, 0.28, so that's not particularly good. And then our 2 interpolation one, the Mansky one, 0.32, and the Sarah one, where are you? The Sarah one, 0.3214, 0.3. So what's the actual value again? Let's have a look. NDVI. That's the actual value. So in this case, our Mansky, no, our Sarah interpolated image seems to be the winner. But that's just for one location, I'm sure. No, no. The lag Y is the best option so far. Yeah, the lag Y. Okay, so, but as I said, that's purely anecdotal. So what we need to do is, once we've got all our predicted models, there's still a couple that we have to do. We still have to do all the time series one. We have to do the weighted regressions, and then the vector model. What's the name of it now? I can't remember. I'll go for it. Once we've got all of them, then we're going to do the evaluation and see for all of these locations. We're going to generate all of the we're going to generate 1,000 or 2,000 random locations within my region of interest, within my shapefile, and then we're going to extract all the values, and then we're going to generate the actual rank of our models. Okay, so save. So that is, in a nutshell, spatial regression. But I said the point of this wasn't necessarily to generate this, to speak about the details of the spatial regression. Is more about generating the spatial regression model and then rasterize the fitted or the predicted values, so that we can compare it with other predicted images within QGIS. Yeah, I think that's quite interesting. So, okay, so as I said, there's our spatial regression equations or models. There's my geographically weighted. We're going to do that as well. And then we're also going to do we're going to also look at the SVM model, what is support vector modeling. We can look at that. And there's the other spatial regression model, the time series regression models that I still have to do. There they all sit. So I still have to do them as well, which I will also do today and add them in. And yeah, so the next couple of video tutorials will all be just about doing what we've done now with all the different models, so that eventually we have an inventory or a list of 10, 20, 30 predicted images based on different models, and we're going to compare that. Okay, Good. That's yeah, I think it's quite interesting. It's different to, yeah, I think this is something quite unique, something quite interesting. Yeah, so kudos. I think it works. Okay, so with that said, let me pause for now. And I will start working on the next couple of videos. Well, I've already done that, so we'll just do the videos on those ones. And let's see where we go to from here. I don't have any particular plan or destination. Our journey just takes us where it takes us. So yeah, there's nothing planned. It is all spontaneous, as I think it should be. And that's the beauty of working in remote sensing. You just don't know where you're going to go to, and every path leads to new adventures, And I'm happy to have you on board. I look forward to your continued presence. Please, boys and girls, please smash those buttons, subscribe button, the like, the forward, the share, all those buttons. Just press them as many times as you can. I'll really appreciate it. Stay tuned. I'll see you on the other side.